know that as we grow, the hurdles will be more. Each time we are washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. To see the sunrise tomorrow, inspire the world to follow. हम सीधे जहाँ GIS है हम की है गुरु.
Okay, so in the course curriculum of Electrical Machine 1, today under the topic of DC machines, we are going to cover the process of commutation and the basic concept of reactance voltage. So this is my objective, to become familiar with commutation process and reactance voltage of DC machine. So let's start lecture number 5 on commutation. So what is commutation? The commutation is the process or the changes takes place in the winding. Changes takes place in the winding during the period of short circuit by a brush. So changes takes place in winding, or we can say reversal of current when it is short circuited, when it is short circuited by brush. So this process is called commutation. Okay, now whenever I will discuss this process of commutation, although the width of the brush width is generally 2 to 3 times width of the each commutator segment, width of the each commutator segment. This is the practical scenario, but during our discussion we will assume that brush width is equals to commutator segment width. Okay, now if we see in figure number A, so in figure number A, the brush is in contact with this segment Q, commutator segment Q. Only Q is connected with the brush. So half of the current is coming from left to right from coil A, and half of the current is coming from right to left from coil C, and this coil B is just prior to undergoing commutation. Now in the very next moment, the brush will be in contact with commutator segment P as well as commutator segment Q, because this is the movement of the machine. Okay, this makes the coil B short circuited. So now coil B, if you look, coil B is short circuited. Now half of the brush current is coming from left to right through coil A, and the remaining half from right to left from coil C as well as coil B. Okay, so if you see, A is not carrying any current because it is short circuited, so half of the current coming from left to right from coil A and half of the from coil C. Okay, coil B is not carrying any current because it is short circuited. Okay, and it is said that B is undergoing commutation. Now if we see in the figure C, the brush is solely in contact with commutator segment P. So half of the brush current comes from left to right through coil A, and remaining half is coming from coil C and coil B. Now the coil B is at the end of commutation. So the coil B is now at the end of commutation. So therefore, during the period of short circuit of a coil B by a brush, the current in a short circuited coil should be reversed. Current should get reversed, which is the changes that takes place in the winding elements during the commutation and brought up to the full rated value in the reverse direction. Okay, full value in the reverse direction. So if you see here, in A the direction of current was this before going to commutation. Now if you look, it opposite reversed get changes, it get changes. So the commutation has takes place. Okay, so this is curve number 1. So B coil was undergoing through commutation process, and the current which is flowing through the coil B before commutation, after commutation, the direction of current has reversed and it has attended the rated value from plus I to minus I in the reverse direction. Now if the changes of current, or rather we can say this reversal of current, can takes place in linear manner, which we have shown in this curve 1, it is called linear commutation. It is called linear commutation. Okay, sometimes this variation of current from plus I to minus I takes place in non-linear manner, which is shown in this curve number 2, and that is called sinusoidal commutation. That is called sinusoidal commutation. Sinusoidal commutation. Okay, so that is called sinusoidal commutation. Now, due to the some reason, the current in coil B may not attain to its full value in the reverse direction due to some reason, if it has happened. Okay, so which is shown in this figure. So full value is I, but it hasn't achieved that full value from plus I to minus I. Okay, so what happened now? The current in coil C is I plus I, whereas coil B is I minus X. Now, so there is a difference of current in which is flowing through this coil C and B, and this existence of this difference of current, which is I minus X minus I, that is X, this will jump from commutator segment Q, this X current for jump from commutator segment Q to brass, and a sparking will occur. Thus, the chance of sparking at the commutation which result in poor commutation. So if sparking occur, it is called poor commutation. And when it occurs, if some anomaly occur and the current in the coil which is undergoing commutation has not reached to its full value in the reverse direction. So what happened? It is the failure of the current in a short circuit coil to reach the full value in the reverse direction at the end of commutation. So that is what we have shown in figure number 3. So this is known as poor commutation. So this is the basic concept of commutation, just overall idea of commutation. Now, what is reactance voltage? The reactance voltage is the self-induced EMF in the coil. The self-induced EMF in the coil undergoing commutation, which opposes the reversal of current. This is known as reactance voltage. So it is the self-induced which is built in the coil, and this is the reason of poor commutation. It opposes the reversal of current in the coil which is undergoing commutation. For linear commutation, the formula is ER equals to 2Li by TC. Okay, 2Li by TC. And for sinusoidal commutation, it is 2.22 Li by TC. Okay, and this TC is called commutation period. Okay, this TC is called commutation period, and L is the self inductance and I is the current which is getting reversed during this commutation. Okay, so this is the preliminary idea of commutation and reactance voltage. Okay, so these are the few reference books for further study, and in my next lecture I will cover, or rather in my GATE lecture classes I will cover the details of this commutation and reactance voltage and solve some problem. So this is all about today's class. Thank you, students.